Hello. In this demo, I will show you how we can implement a map as a service using Axway TSIM TFXSLT transformation engine, and how we can deploy this with Docker containers so that we can scale the implementation and serve different tenant installations. What I have here, it's a packed version of the engine. So the engine is implemented in Java and it's using Saxon to do the TFXSLT transformation. And I implemented previously some XSLT transformations using a tool developed by Axway called Mapping Services. So here I have the solution, which is packed to deploy into two different images with Docker. One, it's a front end, and let me just open this with an editor so you will be able to see the code. As you may see here, I'm using the front end. Actually, there are two layers. One is the processing layer in the backend, which will expose the REST API and basically will be able to execute the transformation. Apart from other stuff like managing the transformations that we deployed for each organization, for each tenant. And we will also have a front-end API, which is going to actually route using a simple algorithm like round robin or other stateful algorithms that are supposed to route the HTTP request to one of the backend containers. So the implementation, it's done with Node.js and Express. As you may see, we have dedicated logs per tenant, and we also have a way to register the containers. So when I will start with Docker Compose my integration, the containers will start in a random order so that the front-end container may start after a backend has already been started. So what I'm trying to do in order to register the backends and do the dispatching is to use a simple datagram stream, and I'm sending to the broadcast message, to the broadcast IP of the subnetwork, I'm sending a broadcast message in which I call the nodes to start. On the other hand, I'm listening on the socket, so when I receive a register from a backend node, I then add in the list of nodes the address of the sender and the port so that I know where to route. Then I create a proxy using the HTTP proxy module that's available for Node.js. And I create an HTTP server that's going to handle the request by forwarding this to the web proxy. The way I'm sending to the proxy is just by increasing a counter, and I choose the backend system based on this index, and then I forward to the address and the port of the backend system. So this is easy as pie. The frontend is going to be serving request as a proxy. Now the backend system, it's actually the one implementing the transformation, but also implementing the Swagger. So in order to do that, I define some endpoints which need to be annotated, and I defined also the infrastructure for generating the Swagger. And then, as you may see here, I configure the endpoints on the Express application. I then configure the Swagger to be registered with the application, and I start my Express application to listen on the given port from the configuration, and I will log the information that the backend has been started. Now, if we go here, I have some packages for the backend and for the front end where you will see the dependencies. And if we go here, you see that the backend depends on Express. Normally, it's the web server. I'm using basic authentication for each tenant. I then have a plugin to call Java from JavaScript. And I also have a plugin to generate the Swagger and to include the Swagger UI in my application. And also I have a stream to be able to send datagram packets to register my nodes and just to format my content in the log. I also have the front-end package, which is going to be copied when I create the Docker image. And this one depends on the HTTP proxy, on the datagram stream, and also on the format of the node. Now, I have some files to create my Docker images. So the Docker file, which is creating the front end, it's copying from the Node.js image. Then it adds some utilities, and then it set up the working directory. Then it's copying the package of the application and renaming it to package.json. It's running the node package manager to install the dependencies, and in the end, it's copying the front end as being the server of the application, and then it's exposing some ports, one for the web server and the other one for the notification on the cluster. And then it just called the start of the task, which is defined in my package .json. Now, similar to this, I have the backend Docker file, which is then installing some utilities. It's installing on the node image OpenJDK, it's configuring the certificates for the OpenJDK, it's registering the Java home, it's setting the working directory, it's copying the package of the backend application, installing the dependencies with Node Package Manager, and now it's copying the files of the application, the endpoints, the one that generates the Swagger, and then the server for the backend itself. And now I need to copy the jar which contains all the dependencies of the TFXSLT engine to do the transformation. And in the same way, I register some ports and I start the application. Now, if we look at the utility file which generates the Swagger, this is piece of cake. It is straightforward from the documentation of the JS documentation Swagger module. I then configure some information about the Swagger, and I say from where to take the endpoints. And then I just register an URL so that when I will load the API docs, it will then create the Swagger for me, and also the Swagger UI. Now, the magic and the implementation itself resides in endpoints.js, in which I have some components to call. Basically, what you need to, I have some utilities. For instance, I will need to have the idea of the tenant each time I do a call to know for which implementation, for which tenant the call should be. And I register some endpoints, and here you see the YAML that documents each endpoint, and that will be used to generate the Swagger. And the idea is that I'm using the Java module to call my TFXSLT engine from JavaScript. I configure the class path to load only the jar which contains all the dependencies of my component. I then create an instance synchronously of the engine, and eventually in the end I have a method which will do the transformation, and this is gonna receive in the body of the request, it will receive the data, that's gonna be the input file, and then it's checking for the input file and for the file that describes the steps of the transformation to be there. And if the files were found, then it's gonna call the engine to do the transformation using these steps with the XSL style sheet from this file and with the body of the input message that has been received as the body of the request. Eventually, this will be sent as the result. So now, in order to see how this works, let me just open a terminal. And first of all, I need to start my Docker because I didn't do that. Sorry for that. And in the meantime, all I have to do is to show you how my Docker Compose file looks like. And if we go in here, you'll see that not with this editor. Let me just put them in the same editor as before. So let me just show you the Docker Compose file. And as you may see, I'm registering several services. I have 6 services in total. 5 of them are executing containers with the image of the backend and 1 for the front end. So here I configure from which to take the Docker file to build the image, a port mapping to expose this engine, and also some configurations from where to take the transformations, which is a shared disk from where to take the files to authenticate the users. It's a dummy example, so I just take the user and password from the file, and where to put the logs. It's going to create a log for each tenant. So now that I have shown you the file, and hopefully that my Docker is running also, I'm going to go in here and just display and run the Docker Compose to build. So I will then create a new terminal just for you to be able to see it better. So I do a Docker Compose build, and it says that there is no in this folder because I started a new one. So let me just do the following. I'm gonna load the old terminal and just see what is my working directory, and then hopefully you will be able to also see the whole path. Yeah, so let's just change the directory to this and then execute the Docker Compose build. And it's still saying that there are no files because I didn't change the directory to where I'm supposed to. So let me just change it to this one. The problem was I was missing an E at the end. So once again, let's then do the build. It's building the images. It's deploying the application. I tested already, so you won't see, you won't have to wait for the whole process to build, to take the image and copy the dependencies on it. It's just copying the files. But then let me fire up the containers, and eventually you will be able to see that they have been registered. And now I have created a log. This is the log of the server. And if I open the log, you will see that, come on, let's just open it with an editor. So you will see that the file is containing the logs of the application and not of the tenant itself. So let's just open this one. Yeah, eventually you should be able to see it. So these are the logs fresh that the application has been started. The front end started, the back ends as well. And now let me just open in the browser on the local host on 9090, which is the port of the front end. You may see this is the Swagger. I have 2 categories, one for the organizations and the other one for transformations. And let me just fire up Postman and execute the transformation, so you will see how this works. Basically, I have here the URL. I don't know if you are able to read it, but let me just enhance the font a bit for you. Should be more readable now, at least the code. So what I need to do, see that I'm calling the front end and not the nodes in the back end. So I like to execute a transformation, but first let me check what transformations I already deployed. So if I go to this folder, you will see that I have a tenant ID here, and I have a transformation called bookshop. I need to use this as the ID of the tenant. So I should have a header with the tenant ID, and this should be the value of the tenant ID. And I also need to specify what should be the transformation. I will do a post on the URL of the transformation, and in the body I should include the input file for the transformation. Now let me just go and grab the input file, and if you bear with me, I have the bookshop input file over here. I will just open this with my editor and just do a copy paste in Postman. And when I call the transformation to be executed, I also need to authenticate, but this is already set up here, so I have my user and password field. And as you may see, this is the result of the transformation. If we look in the header section of the response, you will see that this has been processed by the engine with this ID, so TFXSLT engine 4. If I then execute it again, you will see it's taking still longer because it's going to execute on another node. If I execute again, it's going to execute on the other one, and so on and so forth, because it's using a round robin. And eventually the transformation takes less and less because of the fact that we pre-compile the map and we execute them with the objects that are already stored in memory. So basically this is what we did. And if you look in here, we have a dedicated logs per tenant. So we have a processing log, which is this one. And if you look at the log, you will see a dummy trace saying that this route has been returned okay or whatever, and we authenticate against this file for the tenant. Whereas the log of the server will just output events with respect to the execution of the server and not necessarily regarding the running of the transformation for each tenant. So that was all. Thanks for watching.